Today's session we are going to discuss composite functions, introduction part 3, and the main points: what is composite function, what is composition of functions, and if any function want to be a composite function, what is the rule? And next, example problems before exercise 1.1. This we are going to discuss, and before going to discuss our topic, let's have the prayer. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Right, today we are going to discuss on the part 3 introduction, that is composition of functions. So before going to what is composition of functions, we need to know what is composite function. If f and g are two functions, then x tends to g of f of x is known as composite function. So in other words, we can say the g circle f of x is nothing but composition of functions f and g. And now, what is this composition of functions? This is our topic, right? So the process of combining two or more functions is known as composition of functions. So from this, what you understood, if two or more functions, if you are combined, then that is called as composition of functions. Let's discuss in detail about this composition of functions with a diagram. Let's discuss in detail with a diagram. A, B, C are sets, and here F maps A to B, G maps B to C. Here F and G are functions. Now G circle F, A maps C. So here circle represents the composition of two functions. So let me discuss. A3 is belongs to capital A. You are observe that B1, B2, B3 belongs to capital B, and then C1, C2, C3 is belongs to capital C here, and so on. So there are many elements. So how we will represent this? So first, so what is this B1? B1 is nothing but f of A1. So now we can write B1 is equal to f of A1. Give equation number 1. Same method, what is C1 now? It is g of, because function here g of B1. So now we can write C1 is equal to g of B1. So now this is your equation number 2. So what I'll do is just substitute this B1 value in this equation number 2. So that means 1 in 2. So then what we'll get? C1 is equal to g of B1 means what do you know? F of A1. So this, like this, if g of f of A1 is there, we can write it as g circle f of A1. So we can write g circle f of A1. So from this step, what we can say? So g of f of x1 is nothing but, or we can say g of f of x in general. Instead of A1, I am taking as x in general. G of f of x is equal to g circle f for the composition of two functions. I hope so you all understood how we need to combine two functions. So this is in detail with a diagram, the composition of functions. Let's discuss some of the properties or the examples. Then you can clearly understand what is composition of functions. I said before going to this textbook examples, we are going to discuss one important point. So when this G circle F is going to be defined. So if G circle F need to be defined means the function need to be 1 to 1 and function need to be onto. If these two conditions satisfies, then only G circle F is defined. That is from A to C. But anyway, in textbook examples we are going to discuss now. The first question is this. If A is equal to 1, comma 2, comma 3, B is 4, comma 5, C is 7, 8, 9, and F maps A to B, G maps B to C, be the functions defined as f of 1 is equal to 4, f of 2 is equal to 4, f of 3 is equal to 5, g of 4 is equal to 8. Then find G circle F. So how we are going to find out this, because here itself they already provided these both are functions and then it is well defined, so that directly we are going to find out how is that G circle F. So G circle F, here A place what is there? 1. So that first we need to find out that G circle F of 1. Another one, G circle F of 2. Another one, G circle F of 3. Now how to write this? You already know, when circle is there, remove that and just write the bracket. Means G of F of 1. And here G of F of 2. And here G of F of 3. Now check 4. So write 4. And same method, G of F of 2 means what do you know? 4. And again that is G of F of 3 means what do you know? 5. These are given in your question. So now what is G of 4? G of 4 is nothing but 8. And again G of 4, that is again 8. Again next one, what is the G of 5? That is nothing but 9. So now what is your G circle F? G circle F, so that is equal to, we can write it as, when you take as 1, what is your answer? 8. So now 1 comma 8 comma 2 comma 8 comma 3 comma 9. In this way we are going to find G circle F. I hope so you all understood. So we are going to discuss second one. If F amps are 2 on, f of x is equal to sin x, and G, find F circle G and G circle F. How to find this? So now first, you already observed here in these places. So range of F is subset of domain of G, isn't it? Just check carefully this. This also real number to real number, there also real number to real number, so that this function clearly says to that your range of F is subset of domain of G and range of G is a subset of domain of F. So it is clearly says G circle F and F circle G are possible. So we can say that are defined. So if both are defined, then we can apply normal, that is G circle F of x is equal to, we can write it as G of F of x. So G of, what is F of x here? So sin x, just substitute sin x. And now G of x means you know that x square, but x place what is here? Sin x. So that wherever x is there, in that place I need to substitute sin x. So what is now G of sin x? G of sin x is sin square x. So give this as equation number 1. Now check. We'll find F circle G. So F circle G of x is equal to F of G of x. So now F of, what is G of x here? You found it as x square, just substitute x square. Then F of x square. So here F of x means sin x. So F of x square means sin x square. So that is equal to, you can write sin x square. So this is equation number 2. So from 1 and 2, what we can say? So from 1 and 2, we can say that So this G circle F is not equal to F circle G. So this is about how to find F circle G and G circle F. Just simply substitute that functions. The first point it was here, you need to check whether this function is defined or not. When this function is going to be defined, well, if it is one-to-one and onto function, then only it is going to be. After define what we done, G circle f of x, we can write it as g of f of x plus what is value, sin x, and g of x means you know x square, g of sin x means wherever x is there you need to substitute sin x. So here when you substitute sin x, sin square x is going to be happens. So very simple, just substitute and get your answers. That is about your second. On to the third question, if f maps n to z, f of x is equal to x and g of x is equal to x plus 1 upon 2, where g maps z to q, then find f circle g and g circle f if defined, otherwise not defined we could not find. So let me check first g circle f. G circle f means it is from natural number to the, what is q? Rational numbers. So natural number substituting and we are going to get a this q is nothing but rational number. Let me check. I think this you observe carefully. When you observe this, you are able to it's a one-to-one and onto function, so that we can say that this G circle f is defined. So let me check now how it is possible. G circle f of x is equal to g of f of x. Now g of, what is your f of x? 2x. And wherever in the g of x place, wherever x is there, I need to substitute what? 2x. So it is just like g of x. G of x means x plus 1 upon 2. G of 2x means wherever x is there, what I need to write? 2x. So now we can write 2x plus 1 upon 2. Here, for every x belongs to natural number, x belongs to n. Here n means natural numbers. So when you substitute that natural number, any natural number, you are going to get a rational number. So that this G circle f is defined. Let you go for this f circle G, there q to n. Q is nothing but what? Rational number. Rational number to natural number. So it is highly impossible, so that we can say this as it is not one-to-one, it is not onto. So therefore the function f circle G is does not. So directly we'll write as, so does not exist. So I hope so you all understood this. Move on to next problem, next one, fourth question. In examples, if f maps are to R, f of x is equal to x cubed, g maps are to R, g of x is equal to 3x minus 1, then find g circle f of x and f circle g of x. And also prove that f circle g is not equal to g circle f. So first, in this solution, what is given first? Given here, f maps are to R, and the one g maps are to R, so that it's clearly saying that satisfies one-to-one and onto function. Now let me move on to this. F of x is equal to x cube given, and g of x is equal to 3x minus 1 given. Now first one, find g circle f of x. G circle f of x, we can write it as g of f of x. So what is f of x here? That is x cube. Just substitute x cube. So now g of x means 3x minus 1. G of x cube means wherever x is there, what I need to substitute? X cube. So now 3x is there, so that x cube minus 1. So now you got g of x cube is 3x cube minus 1. That is nothing but g circle f of x. So this gives us equation number 1. let's move on to the second one. It is what? F circle G. So F circle G of X, we can write it as F of G of X. So here now, F of, what is G of X? G of X, you know that 3x minus 1. So right here 3x minus 1. So now f of x means what do you know? X cube. So wherever x is there, substitute 3x minus 1. So now, so here x cube means 3x minus 1 whole cube, because x place here 3x minus 1 is there. Because of that reason, wherever x is there, 3x minus 1 we substituted. So this gives us equation number 2. I think from 1 and 2 clearly you all understood that this 3x cube minus 1 is not equal to the 3x minus 1 whole cube. So we can write from 1 and 2, G circle F is not equal to F circle G. This is about our proof. I hope so you all understood. So what we done here, first F given, that means F is R2R and G is R2R. That means F maps R2R, G maps R2R, F of x x cube, G of x 3x minus 1. Just what we done, we just substituted F of x and G of x values to get our answer. Understood now? So I hope so you all understood. Let's move on to the next problem, that is problem number 5. Right, let's move on to the next one. If f maps R to R, f of x is equal to x square plus 2 and g maps R to R, g of x is equal to x upon x minus 1, then find g circle f and f circle g. Here again clearly you are finding that it is R to R, that function also R to R, so that g circle f and f circle g both are defined. So now we are going for how to find g circle f and f circle g. So you need to write given what are there or those are, and then you have to solve. I'm directly solving now. So now first I'm writing what is f of x, x square plus 2, given this all. What is our g of x? That is x upon x minus 1. Now first one, g circle f of x. So again g of f of x. So g of, what is f of x? X square plus 2. So now just substitute this x square plus 2 wherever in the g of x plus x place. We need to substitute x square plus 2, because here g of x square plus 2. So now x means what I can write? X square plus 2 upon, again x means what I can write? X square plus 2 minus 1. So now this we can write x square plus 2 upon x square plus 2 minus 1 plus 1. So this is about your g circle f of x. So this is your g circle f of x. So now we are going to find out what is f circle g of x. So f of g of x. So f of, what is your g of x? X upon x minus 1. So substitute that x upon x minus 1. So what is f of x? X square plus 2. So wherever x is there, substitute this form. So now you can write x upon x minus 1 whole square plus 2. So this we can write x square upon x minus 1 whole square plus 2 in the form of a upon b whole power m. So here I'll write a upon b whole power m is equal to a power m upon b power m. So by using that, so now LCM take x minus 1 whole square, x square plus 2 into x minus 1 whole square. If you want to simplify more, or you can write up to this. So this is about your g circle f. It's nothing but x square plus 2 upon x square plus 1. And f circle g of x is x square plus 2 into x minus 1 whole square upon x minus 1 whole square. So this is about how to find G circle F and F circle G when when f of x is equal to x square plus 2 and g of x is equal to x upon x minus 1. So this is about your complete fifth problem. I hope so you all understood. Let's move on to the next problem again. Right, we are going to discuss this last problem of this examples of your textbook. So now, what is your sixth question? Verify the associativity of the following functions where f maps n to z naught and f of x is equal to 2x, g maps z naught to q, and g of x is equal to 1 upon x, and h maps q to r, h of x is equal to e power x. So here you have to understand this clearly now. This z is nothing but z is nothing but your integers. So now what I'll do here, just whichever they written, those all things I was written. Now what is now in this place? G circle f. G circle f is nothing but natural number to q. Same manner h circle g is nothing but g naught to r. Now h circle g circle f means it should be n to r. So now same method I was written remaining also, that is h is q to r and g circle f n to q, and h circle g circle f is n to r. From this what you observed, h circle g circle f is n to r, h circle g circle f is n to r. So that the function is defined, so that just I was written this given part, and now both functions are defined on set from natural numbers to the real numbers. Now we have to show that h circle g circle f of x is equal to h circle g circle f of x for every x belongs to n. Here, why we need to show this means because they said that verify the associativity, and if this both are equal happen, then we can say that associativity is verified, otherwise it's not. So now let me find out now first one, h circle g circle f of x. So now LHS I took here, okay? So that is equal to, what can I write? This we can write h circle g of f of x. So now again h circle g as it is. What is my f of x? F of x is nothing but, you know that, 2x. Just substitute 2x. Now this h circle g, how can I write? H of g of 2x. So now h of, what is g of x? 1 upon x. G of 2x means 1 upon 2x. So write 1 upon 2x. Now h of 1 upon 2x. So wherever x is there, you need to substitute 1 upon 2x. So h of x means e power x. So that h of 1 upon 2x means, so that is e power 1 upon 2x. Give us equation number 1. Now same method, let me go for second part also, that is h circle g circle f of x. So this we can write it as h of g circle f of x, and still this we can write it as h of g of f of x. So now this is h of g of, what is your f of x? F of x is nothing but 2x. So substitute that 2x. Then h of g of 2x is nothing but, already found, that is 1 upon 2x. Then h of 1 upon 2x means, that is also you already found, e power 1 upon 2x. So e power 1 upon 2x. This is your equation number 2. So at last, from 1 and 2, associativity is verified. So this is about your final problem. I hope you all understood. Let's move on to the next. Next session we are going to discuss exercise number 1 of composite functions. And now for all my students, it is my suggestion kindly check nearby your families. If anyone is needy, kindly help them in this tough situation. May God bless you all.